Hello everyone, welcome back to another video from Winter Forest. Today going to continue Leetcode challenge. Today's challenge is called Construct a binary search tree from Preorder Traversal. So here is the description. He said return the root node of a binary search tree that matches the given preorder traversal. Recall that this is the reminder tell you what is a preorder BST tree. So what they say? They say binary search tree is a binary tree, so only have a root and left and right for every root. Any descending of a node.left has value smaller than node.value. So from everything on the left and the descending order, so the subtree and then next the subtree all suppose smaller than the node.value. And any descending of a node.right has value greater than node.value. So everything on this root on the right and descending suppose greater than the node.value. Also recall that the preorder traverse tree displays the value of root first. So the A, it is the root. So basically you see this is the input. This is just let you reorder them. So A, 5, 10, 1, 7, and then this is none of it. Then try. What I'm going to do it is in this screenshot. So basically you started with the node in the A position. Then you have a minimum value is going to the negative infinity loop. And the upper limit value is max, is going to the integer to the max value. Then you move on the first step. It is the second node, 5. Then you change update because you treat that this is correct. Then you treat that the upper node, it is A. So the max value is A because of go left. You first go you left, then go right. Now you treat that the no limit is negative. You treat all of this is left. So you continue find 1. And you still go into the no limit is negative and the upper is 5. So you continue going to 1. Then the upper node is 5. And you continue go to 7. You go into the 7. You still say and the upper limit, the upper is trying to put the 7 under the 1. So you're going to upper is 1 and the no limit is infinity, but this is not correct because 7 is greater than 1. So you go into change it to 7 and limit. So 1 under it, 7, and put the 7 in 1 and in here. 1 and put 7 in here. 1 and 5, but still not correct because 7 greater than this one. So you move to here. So you put a 7. The low limit is 5, and then the upper limit it is 8. Then you go. So you put in here 7. Put in here. Now you find a 10. Find a 10. You say the low limit is 5 and the upper limit is 7. Now once 10 coming, then the 7 not correct. So you're going to change the low limit 7 to under this 10 and the upper node is here. Now you move 7 to here and move the 10 back to here. So just write the code, it will make sense. We need an index value, so the looping from 0 up to this node.length. So going to have an index equal to 0. And then we have actually need a help method. The help method will return the tree nodes. you will pass in this preorder, and then you have the min and have the max. So you actually to change the order, swap the order in here, swap this kind of order, move on, then you're going to swap the order. And in here, you first are going to do, just make sure this is not a empty array or no, or names equal to 0. In this scenario, you just simply return null. Otherwise, you just return this helper method. In here, you have the root preorder this. You have the null limit and the upper limit. The null limit, so it is, he said it's integer, so we're going to integer dot min value, and the upper going to integer max value. Now we just need to travel left and right. And we need to find the best scenario. So the best scenario only up to index. When you go into stop the infinity loop, recursive loop, it is when the index greater or equal to the preorder dot length. Then just return null. Otherwise, you're going to loop it. So you actually first get the value. So your first rows, this is the A. Then you have the tree nodes. Set it to null. And you actually return this node. You're going to keep push this, calling this helper again. So when you're going to call the key greater than main and key smaller than the max. So until you loop finish it. Because inside you're going to update the min and the max. Can just call this just key. Every time you come in, once just update the index and then you move to the left first. Then you move to the right. Because the max suppose greater than the key. Let's test it. Okay, semicolon missing in there, here. Yeah, it's done. You see, if it's nullable, you just get a null. You see, push to the main. Submitted. Yeah, it accepted. Thank you for watching.